Hello, fifth graders. Do you feel like you're in Jumanji? If you can, Google the Burundi drummers. They're very famous and they are, I'm going back to my camera here now. You can find a lot of their videos online. These are the colors of the Burundi flag, and they are celebrating happiness and welcome. It's a celebratory drumming and dancing event. So just kind of double checking what you have so far done in your books. We are starting chapter 7 on the changing forms of energy. This we're kind of go through a little bit fast. The point here is that energy can change forms, and then we're going to be spending some time on sound and light. So as you watched or look at this picture here, the question asks you, where does he get his energy? And hopefully you kind of thought of it at school. They were talking about it comes out of his feet, it comes out of his legs, but where do they get energy? And we said the dancer, or came to a conclusion, I guess, the dancer gets energy from the food that he eats. That goes to how he's changing some chemical energy into the energy of motion, the transformation of energy that we're going to be covering in lesson 1. It also asks you, how do you know he has energy? How do you know that there's energy involved in this picture? And a lot of kids said because he's jumping. You can also say that he's moving in any way. So we're going to be spending some time on how energy is transferred and transformed. Let's see, I think I stopped it. No, I didn't. There's one where I can get rid of all of these, and I thought it was, there it is. Okay, so as you were reading here, this was the inquiry try it that we did about wind-up toys, and I believe I posted a video of a little science man, but the kids at school were spending some time with the Peep and winding it multiple times, and then got a chance to time that. And then we talked about these two. Of course, we had a tornado drill, so I'm still waiting to finish this with my second class. So this skill that you're going to be seeing a lot of examples in this book is the cause and effect of things. If you read this about heating living in Northeast Ohio, you know about potholes in the road, or as my dad calls them, chuck holes, and that's caused because of things expanding when they're hot and then contracting and going back and forth, and that can break up cracks in the road. But they also do the things here on railroad tracks. That's what this article is about. If you look on bridges, you might see V's that look like this, so that when they expand in the summer, they can go like this. And if they contract in the winter, it's still safe to drive on the road. Think about it in the past, if they were like this, and they keyed it up and they wanted to expand, it would kind of break or bend. And that's what this article says. There are a lot of cause and effects. The one we went was that heat, and one of the effects was expansion. And that kind of goes along with, and since there is expansion, the builders left gaps in the railroad tracks, and there's a few others that you can find in there, but we did write those. There's like I said, different examples. Okay, so let's start with lesson 1. Exactly what is energy? We did read about Newton's laws of motion, so where do motion and energy come in? So on the Let's blog about it, this person, Katera, was at a construction site, and she was citing all the different types of energy that she saw, and then asked, what other types of energy have you seen? Now she mentions lights, and I think she remembers maybe sound of them talking to each other, so and the things crashing into sides of the building. But we talked about chemical energy, maybe from the workers moving, kinetic energy, things moving, heat energy, I'm going to sneeze, Excuse me. So then when you start this chapter, it says circle the penguin that you think has the most energy and tell how you made your decision. So a lot of people thought it was just this one because he had just taken off and he hadn't burned that much energy. Another one said right about here because he's going really fast right before he lands, kind of going in with the potential and kinetic energy that they remembered from fourth grade. But the correct answer is actually the highest penguin. Now, I know it's the highest penguin because this penguin has the same, this is probably the same penguin, it's a motion picture, but he has the same amount of potential energy based on his mass. His mass has not changed, but his gravitational potential energy has changed because he's higher up in the air. And since the total amount of energy is not only how fast he's moving, but also how high he is off the ground. So over here, when you read about energy, I highlighted that energy is the ability to do work or cause a change. Now, the very first sentence says energy has a different meaning in science, and it does. Because when you talk about even doing work in science is how much mass is moved over how much distance. So if you were to write a 10-page report, but you were just pushing down on these keys, you probably wouldn't be considered doing all that much work. So energy can change an object's motion, change the color. Think about heat energy changing the color of your bread to toast, maybe the shape of something, perhaps melting. It can warm something up, even you weren't getting warmed up, and some other characteristics. So energy cannot be made or destroyed is another fact that I highlighted, and it can move from one object to another. So here's that idea of cause and effect again. Complete the graphic organizer below. List one cause and one effect found in the paragraphs above. Let's say when you put energy, the cause is maybe turning the key. I'm going to say the toy key, which would use chemical, and the effect would be the toy moving. You could also put energy, it might change the color of something. When the penguin jumps higher, he has more energy. There's a couple of them in here. So then the next page is specifically potential energy. Ooh, let me get it in there so we can see here. And potential energy is just the energy that is not causing any changes now, but could possibly cause change in the future. So I'm just going to move, let's see, this cup over here. And if I put this pen on there, most of us would say, well, maybe this pen could soon fall. So how much change could it cause? So obviously this pen might not cause as much change as my cell phone because the masses are different. Something, if I were to drop a pen on your head, probably wouldn't hurt. But maybe if you dropped a cell phone on your head, it would hurt. Can see that that would be two different things. There is such a thing as called gravitational potential energy, which depends on the position. Think about if I were to drop this on your head from right above it, probably wouldn't be a big deal. But if I held it way up high and dropped it, it would cause more damage or more pain. So gravitational potential energy depends on the position of the object. And then elastic potential energy, I think I have one over here. I've had to hide them. Let's see. Come on. I should have got that one ready here. Where did I put those? I think I hid my rubber bands because the kids were... Okay, let me pause this and get some rubber bands. So elastic potential energy would be in a rubber band that you could stretch like that. Obviously, when you let it go, there would be a change. And when you wound this, that activity at the beginning asked you what cause that motion. And I had one of these and I left it out, which was my mistake. And the kids like, let's see, and you can see the gears in there. Let's see if I can hold that up. You can see the gears. And what the gears did was sort of compress this coil or this spring. And then when you let it go, it was supposed to jump all around. But the 5th graders and 6th graders, I don't know what happens there, but you can see sort of, so we were storing some energy in the coil here. The second kind of energy that you read about, just kind of quickly here, was that energy of motion. And if we take how fast this or how much this peep is moving, plus the mass, and if it was up on a table or something, both of those two things together are called, mechanical energy. So highlight the word kinetic energy, that energy is due to motion. It depends on how fast it's going and how much mass it has. So down here, under draw conclusions, it asks you to underline the facts in the 3rd paragraph that support the conclusion that a basketball has more energy than a beach ball. Here I said since the basketball has more mass, it has more energy. If all this traffic is moving at the same speed right here, which vehicles do you think would have the most kinetic energy? And I would be the trucks, or any vehicle that had a lot of mass. Okay, so when I'm going to go ahead on and add this, you could stop it because we didn't really do this one right here, but it's just an application of what you read. So energy is everywhere. You can find energy in different forms everywhere you go. Anything in motion has kinetic energy, and objects raised above the ground have potential energy. So since I didn't assign this yet, I'm going to tell you to pause the tape here, but it asks you to label, to look at the scene shown here and find as many examples of kinetic and potential energy as you can. Label the scene just using the key K for kinetic and P for potential. So to me, I think this is for the train here. You could tell it's moving because it's blurry, so I'm going to call that kinetic. These people are raised above the ground, so they have potential. This person is way above the ground, but doesn't appear to be moving, so I'm going to even call that maybe gravitational potential energy or just potential energy. So over here, this person is walking, so I'm going to go kinetic. Let's see here, nothing there. Do you see any more of these little, okay, here's this person. Now they're raised above the ground, so I'm going to go ahead and call them potential, but they're also moving with this UPS guy, so I'm going to call them kinetic. And this person is running, but he's holding his books, so do we put kinetic or potential? Now, I'm not going to say either one of those is wrong. You can just, depend on what you're thinking of, I'm going to call this kinetic here. Now, if you take a look at this picture and see how good of a detective you are, you can see what this delivery guy is about to step on. And if you've noticed, this kid right here is actually carrying our science book, if you take a look at it. You're going to see this picture again. But I don't see, did I forget any? You can email me if I did. I don't see any more little white squares. But in any given moment, you can see all kinds of energy. Think about this person, sound energy. These people might be talking. She's about to have some chemical energy here. There's chemical energy probably in the gas there. This kind of scares me that they're potential energy, because does that mean one of them is planning on, hopefully, or not falling. Okay, so that's what we have highlighted so far, and then we'll go and assign maybe some energy changing forms a little bit later. I hope you guys have a nice Wednesday.